Okay, so here we are at graph number 2, and we're still going to follow through the same steps that we did before. So step 1, find the x-intercept, and remember that's going to set the numerator, x squared equal to 0, and solve. So I'll take the square root. So my x-intercept is 0 again, so this is 0, 0. Remember always that the y equals 0 for your x-intercept. The vertical asymptote is going to be found by setting the denominator equal to 0. So x squared minus 1 equals 0. Then if I add 1 to both sides, I get x squared equals 1. Square root. This time I have asymptotes, positive and negative 1. That's a delight. I can graph those now or later. Yeah, I'm going to graph these as we go. So 0, 0, and then positive and negative 1. So one of my asymptotes is positive 1. This should be dashed, but it's not. And then at negative 1. Okay, the next thing I need is my horizontal asymptote. And remember, to find that horizontal asymptote, I'm looking at the leading ones, the first two terms. So this would be this over that. So y equals x squared over x squared. Well, what's x squared divided by x squared? 1. So that's that. Right here at 1. Okay, your asymptotes are supposed to be dashed, but if they're in highlighter, they can be solid. I really prefer dashed, and I kind of regret that that's not dashed. Please forgive me. The y-intercept, beautiful people, remember that happens when x equals 0. So again, you'll plug in 0 into the original equation, so y equals 0 squared over 0 squared minus 1, which is 0 over negative 1, which is again 0. Which is kind of already there. Now, for finding extra points, please pay attention. We need points between and beyond. So for this previous example, we didn't have a vertical asymptote, so there was no beyond, between thing. We just went for the basic. Now, we want between and beyond. So that means between these two asymptotes and beyond. And I'm going to go for at least 3, but if I need extras, I'll just give myself extras. So this is what? Let's label this. This is negative 1. This is positive 1. So beyond negative 1, I probably want to skip around at least a little bit. And I'll go maybe negative 3 and negative 2. And let's see how that suits me. So I'll go negative 3, negative 2. And now between, well, I need numbers that are between positive 1 and negative 1. Don't make it too complicated. I'm going to do negative 0.5 and positive 0.5. And then I need some points beyond. So I'm going to go, if this is 1, I'm going to go 2 and 3. And then see what we get. So this is where we have our trust exercise yet again. And I'm going to plug in negative 3 into this equation. So negative 3 squared over negative 3 squared minus 1. So this is 9 over 9 minus 1. 9 over 8. So that's like 1.1. Trust me, now this is where you would go to your calculator or do it all by hand and plug in negative 2 into this equation. And if you did, you'd get 1.3, and then you get 0.3, negative 0.3, and then you'd get negative 0.3, and then for 2, you'd get 1.3, and for 3, you'd get 1.1. I'm not showing you how to plug these in because I'm kind of trying to trust you that you can do that. So now I'm going to graph each of these. I probably don't want to go by, well, I'm not going to change my scale. Tell you what I'm not going to do. I'm not going to change my scale because I already drew this as 1. So I'm going to leave this as just us going by 1. And I'll be okay with it. So plot each of these points on your graph. Okay. So I have negative 3. This is 1.1 just above it. 1.3. Negative 0.3. I know it looks a little crammed in there. Apologies. And then 0.3, and then we had 1.3 and 1.1. So if I'm using my asymptotes to guide me, then I know it should approach this line, and it should approach that line. And there it does. I know it should approach here. So I don't need a million points because my asymptotes really do help me guide my graph. and then this is going to approach from this direction, which is cool. And then you're thinking, okay, this is wonderful for beyond and beyond. What about between? Well, we have, I know it's hard to tell, but here's what we're looking at. Looks like that, with two asymptotes on the end of it. So I'm going to connect those almost like a parabola, except parabolas go out forever, and these will kind of just stay in the middle, just like this one. Now, this you actually have seen before, somewhat recently, on your warm-up. This is the same family of graphs that this one was on the back side of your paper. So that's what that will look like pretty much every time. All right, let's try another one. We're going to follow our steps one more again. X-intercept, we're going to set what? Equal to 0. We're going to set the numerator equal to 0 one more time. So we have x squared minus 3x minus 4 equals 0. You can trust me to factor. Equals 0. And so x equals -4 and -1. After we factor, like, so x minus 4 equals 0. So that's wrong. This would be equal to 0, and this would be equal to 0. This would be +4 and -1. I missed that negative sign. So the thing is, though, these are intercepts, beautiful people. They're intercepts. So what does that mean? Well, my intercepts are 4, 0, and -1, 0. 1, 2, 3, 4, 0, and -1, 0. Vertical asymptote, we're going to find by setting the denominator equal to 0, and find that x equals 2. X equals 1, 2. Can you see that? Probably not super well. There you go. Okay, can I pause? 1 minute. Sorry. Go back. Right here. I forgot the domain and range. The domain, moving from left to right, we do have some holes here. It doesn't go consistently. These are my restrictions. So x cannot be 1 or -1. For the range, that's when I'm looking up and down. Any restrictions there? Yeah, there's a restriction here. It's never going to be equal to that. So I'm going to say y is not equal to 1. Your asymptotes will most likely, sometimes, most of the time, be the answer to that. Okay, thank you for that wonderful commercial break. Horizontal asymptote, how do you find that? Well, that's the one where I'm looking at the leading ones. And if I'm going to write this as a fraction, I would write y equals x squared over x. This I can reduce. So this is y equals, what's x squared divided by x? Just x, because you had 2 on the top, 1 on the bottom, so just x is left. That is a wonderful thing that we like to call a slant asymptote. So this is not a horizontal one, because horizontal just goes like this. The line y equals x goes like that, because remember the slope is 1, so you'd go up 1, right 1, up 1, right 1. So if the y-intercept is 0, you go up 1, right 1, and you keep doing that. And then you're going to draw that line, but dash it for me. Okay, so there's that line, and then we need our y-intercept, which happens when x equals 0. So I'm going to plug in 0, with 0 squared is 0, minus 3 times 0, 0, minus 4, over 0 minus 2. So this is -4 over -2, so y equals 2. What is this as a coordinate? Because we're talking about an intercept. This is 0, 2, 0, 2. There you go. So points between and beyond seem a little tricky for this one, but it's really not that bad. Here's what we're going to do. Here is my vertical asymptote. I need some points to the left, and I need some points to the right, basically. So let's pick some points to the left. I'll say I'm going to go far out. I'll go -6. I'll skip around, do -2, maybe 1, because I already know what 0 is. What else? Let's go for some odd numbers. 3, 5, and 7. I know, I wasn't cussing, but that's just what happened. So you plug those in, and you get -6.25, -1.5, 6, -4, 2, and 4.8. Go ahead and graph those for me.